Big Slick here, and today we're going to calibrate and do a quick tutorial and review of a Sencor TF46 portable Super Cricket transistor and FET tester. So the first thing we're going to do is calibrate it. You start out by mechanically setting the needle to 0. After that, you're going to connect up, as they show in the service manual, you have to connect the resistance between the yellow and red test leads. Have that in series with your DC milliammeter, and at that point, when you engage the leakage test, it should be full scale with 2.5 mA, as you see here on my fluke meter. When you perform this test, I should say that all of these switches on the left side should be in the out position. And the first calibration pot was the one at the far end here. That is R38, which is the one that you adjust first. So then next, we will adjust R39 for 250 microamps. So you'll reset the resistance until when you press the leakage button, you would have 250 microamps. Now I've readjusted the resistance for 250 microamps when I press the leakage button here. As you'll see, it's reading 0.25 mA. And you want to have the scale right between the 200 and 300 on the microamp range. Okay, the 250 microamp range is right here. As you'll see, this is 100 microamps. The next line here is 200, the next line is 300. So you're going to be right between the two here, and as you see, this is the microamp range, and this right here would have been 2500 microamps. So we have this calibrated. Next, what you have to do is go back and repeat the first step, and you need to go back and forth until both of these are calibrated correctly. Okay, as you see, when I went back to recheck the first calibration point, it's off. So now we have to tweak that outside pot until we get it back to where we want it to be full scale. Okay, it's redialed back in, so now we have to recheck the 250 microamp range. Out in at 250 microamps, and you can see that it's almost perfect here, just about a hair of a needle, and I'll go ahead and give that a slight adjustment. The 250 microamp adjustment is the second one in from the right side. Okay, that's dialed in nicely there, so we'll go back and recheck the first calibration point again. Okay, the first range is off just a hair this time. Okay, that's dialed in nicely again, and we'll recheck the other one again. Okay, as you see, we're spot on the calibration now. 250 microamps. We are at the exactly between the 200 and 300 on the scale. And for one more time, we'll check full scale. 2.5 milliamps, full scale. And we have performed the leakage calibration. Okay, the next step will be to calibrate the beta. Okay, this transistor, a 2N3904, generally tests around 350 beta. Okay, it's bringing in at, it's testing 339. So we'll test it on the other machine. It's testing 342 here. So it's approximately 340. 340 beta. So on the scale, the beta scale here, the second line over here above the 200 is 300. The next line is 400. Okay, that looks to be just a hair below the halfway mark from my vantage point between the 300 and 400, so we're going to call that accurate. Okay, next up is a germanium power output transistor. Okay, it's testing 45, and as you see, it's this transistor right here. Germanium output transistor, and if I put it on the small signal test, which I believe would be very similar to what the M testers here are using, When you do the gain here, you're testing around 45. So keep that in mind, it's 45. If you test it the way this machine will properly test it using the output transistor test, you're getting upwards of, I guess, approximately 65 or 70, right around there. Okay, 2N5401, PNP testing around 95. 2N5401 on the Sencor, testing just a hair below 100. So, perfect accuracy. BC548, NPN transistor with a gain of around 345. Okay, BC548 here on the Sencor. There you go, just a hair below 350. Okay, we're doing the FET gain calibration now, and since I do not have any FETs here, and I certainly don't have any with a known gain score, we're going to use the approximate calibration procedure that's in the Sencor manual. You adjust to 0.4 peak to peak, which is the second calibration control on the left side in, facing the front. So we'll go ahead and we have it set it up correctly here. Press the gain, and as you see here on the portable scope, the peak to peak is 402 millivolts. So that should calibrate this acceptably well. And so how do you use this? First of all, this can be used as an in-circuit pass or fail type of test for any transistor or FET. The key to this is, number one, you have to have the piece of equipment turned off, and number two, you have to use your voltmeter to make sure that there is no voltage on any lead of the transistor that you want to test. Otherwise, you will damage the Super Cricket. So, assuming that you followed those precautions, you simply connect. You can pretend right now that this is in circuit. You would just connect this any way, it doesn't matter which lead goes to where. Okay, so now you have the transistor, and like I say, this can be in-circuit connected. Now, I find for an in-circuit test, it's nice to engage the speaker, which has a switch tucked in to the storage compartment. You can turn that on. And then all you do is, once you have the device on, so we've turned it on, you'll just rotate this through each position. And if the transistor is a PNP, you should get a positive test somewhere in the PNP side. If it's NPN, you will get a beep and a meter reading on two positions at the NPN side. And so since you don't have to know what this is, you simply just make a clockwise turn until you start finding an indication. And if you don't find an indication anywhere, the transistor is open. Okay, now as you see, we have the audible indicator and we have a reading on the meter. The meter is just simply a deflection. This simply shows that the transistor is capable of amplifying. This here is not a reading, it's just an indicator. And there is the second position you will find. This is all you are going to get for an in-circuit test. You are simply going to get the audio beep in two positions and a meter deflection in each of those two positions. If you want a more sophisticated test of the transistor, such as leakage or the beta, the transistor needs to be removed from circuit. So in this situation, since this is already removed from circuit, I can show you how to do that. So again, if this was just a random transistor out of circuit, now you would just do the rotation until you get at least the first reading. So I'll start down here at the bottom, being that this is an NPN. Okay, no reading, no reading, no reading, no reading. Now we know we're going to get a reading on the next one. So if you want to test this, the first step you do is you press, as soon as you get that beep for out of circuit testing, you'll press the leakage button. And for silicon transistors, you should get no leakage at all on the meter. Any leakage is a defective silicon transistor. If this was a germanium, there's a chart on the back that gives you an idea how much leakage is acceptable. So then what you do is you switch it to the next position where you're getting the audible beep and the meter deflection, and you test leakage for that side too. And as you see, we have no leakage here. So far this seems to be a good transistor. You know it's amplifying because of the audible beep and the meter deflection, and you know that it doesn't have leakage. But if you actually want to now test the gain, you have a choice. You need to decide whether you have, I'll hold this in while I'm talking. You have to decide whether you have a signal transistor or an output transistor. When in doubt, just use the signal transistor. But you can pull up a data sheet, or you can just generally tell by size. If you have a small transistor such as this is going to be a signal transistor. If you have a large transistor that's in the output stage or in some type of power supply stage, then that is going to be a output or power transistor. So you would pick the correct one. But if you can't figure it out from anything, just use the signal transistor setting over here. So next you will press that in and you will hit gain. You're going to do this for both positions of the switch where you were getting the audible indicator. And only the higher of the two readings is accurate. So now you could tell right here this is going to be the accurate position because we're getting a reading of 350. If we go back to the other position, we hit gain, we're getting a much lower reading. So the correct reading for this is 350. It's the higher of the two readings. So now you know the beta, you know the transistor has no leakage, you know what type it is, it's an NPN, and even with this, you can figure out with the help of the manual what the basing is. It's not as convenient as an M tester for this, but it is, you know, it does work well, and you can decipher what the basing is from this looking in the manual on the chart. The process is the same for any other transistor, but I will show you the germanium because you will be able to find leakage in this. Now, this is a good germanium, but it does show leakage because all germaniums show leakage. Okay, we have the germanium transistor connected to the Super Cricket, and so now we're going to go through the process again. We're starting at position 1 here. Okay, bingo, we have a reading. So the very first thing you're going to do is hit leakage, and you're going to read that scale right there. So according to this, it's got about 40 microamps of leakage in this position. Now we're going to go to the next position, and there again we're getting the second reading there, which is correct. So now we'll hit the leakage again, and on this position we have a little above 50 microamps, probably around 55 microamps of leakage. And if you hold it in a little longer, it may rise a little bit, but it's basically going to stay right around where it's reading there. So we're getting to about 60 microamps of leakage. This is a good germanium output transistor. So now if you want to test the gain, you'll hit the output transistor on this, and we'll hit gain. Now the reading at this right here is only about 17 or 18, so that's probably not going to be the correct position to test it. So we'll move it to the other one where we're getting the beep. We'll hit the gain, and so there you go. The higher of the two readings is the correct one, and it's testing around 65 here, 65 to 70. So that simply shows you how to use this machine. It's a very easy machine to use. And you can go through all these positions. It's never going to hurt the transistor. And if you get a positive hit in more than two positions, then you should suspect you have a problem with the transistor. You're only going to get a hit on a good transistor in two of the switch positions. And in both positions, you're going to test leakage. And in both positions, if it's important to you, you're going to test gain, which is the beta. For most needs, as long as the transistor is amplifying, that would be a sufficient test. But if you need to either match transistors, you're going to want to test the gain, or if you suspect that a transistor has too little gain, it's old, maybe worn out, then you might test it for that reason too in the gain position. Now I'll test a JFET and show you how that is on this machine. Okay, I've connected a 2N5257 JFET to the Super Cricket, and we'll see how this works. It's the exact same process. You're just going to start at the top and do the clockwise rotation. And if this is a P channel JFET, you will get a reading in two positions on the P side. If it's an N channel, which I know this is, you're not going to get a reading until you get to the N side. And again, it will be in two positions. Okay, so right off the bat down here on the N side, we're getting a reading. So to test leakage, you'll do the same thing as before, just press leakage. For a JFET, you shouldn't get any leakage. It's a silicon part. So next position, we're also getting a reading. You're going to hit the leakage there. When testing for gain, on something like this, all it is an electronic switch, so you're going to go full scale, and you should get it in both positions where you're testing, where you're getting the audible beep. And as you see, it's going to go full scale in both positions. And I have it on normal FET here. And that concludes the tutorial for how to use a Super Cricket. It's an extremely simple machine to use. It can work in circuit or out of circuit, but it does work in circuit for at least a pass-fail type of test. And for out of circuit, it can tell you a lot of parameters. It can tell you the beta, and it can tell you the leakage very accurately. Now, you might ask yourself, is this better than one of the M testers? That's a hard thing to say. I would say it's rather equivalent. It's maybe not quite as easy to use because the M tester is fast, and it does show all the parameters that you have, including the pinout, which from that standpoint makes the M tester superior. I do think as far as trying to match output transistors, such as if you're working on an old power amp that uses TO3 outputs, I do think the specialized output transistor beta test on this is superior. So that is mainly what I use something like this for, but this is the second unit that I have of these, and so that's why I use this. But for using the small signal ones, I generally use the M tester. If I wanted to test in circuit, I would pull this out, but I usually just use a diode test on my Fluke. So that gives you some of my thoughts on the unit. Do I think this is worth owning if you're a serious technician? Yeah, if you work on transistorized gear, I think that you can find value here. But it's a luxury. You can get by with the M tester, I think, very satisfactory, and they're cheaper. They take up a little less room. But if you want to upgrade to something that is possibly a little better at matching output transistors, then I think this is a nice addition. And once you get to use these, they're very easy to use. They're fast and efficient. The only thing that isn't as nice is it's much harder to determine the pinout versus an M tester, which will tell you right on the screen, pin 1 is this, pin 2 is that. That's very convenient for when you're substituting, because not all transistors have identical pinouts, and so therefore you need to make sure you're putting the substitute in correctly. So the M tester has the advantage in most situations, but these don't cost that much money, and if you want to splurge and give yourself a treat and have another gadget on your bench, this is a nice unit to have. Thanks a lot. Hope you got something out of it. Bye.